Hey, hello there, and welcome back to another video. So today it is December the 7th, and well, let's see what the Advent of Code puzzle for today is. So day 7, oh, it seems like we are leaving the island. You can see the star here. So let's see what this is about. Day 7, camel carts. Okay. So your all expenses paid trip turns out to be a one-way 5-minute ride in an airship. Airships are like kind of like zeppelins, right? Yeah, cool. At least it's a cool airship. Yeah, indeed, it is cool. Airships are awesome. Unless it's the Heisenberg. What was the name of the one that burned away and killed? Well, I don't remember, but it's a long time ago. We should make airships again, I guess. It drops you off at the edge of a vast desert and descends back into Island. Did you bring the parts? You turn around to see an elf completely covered in white clothing, wearing goggles and riding a large camel. So yeah, this is a Wikipedia link for dromedary. I think I know what a camel is. Did you bring the parts? She asks again, louder this time. You aren't sure what parts she's looking for. You're here to figure out why the sand stopped. The parts? For the sand, yes, come with me, I will show you. She beckons you onto the camel. After riding a bit across the sand of Desert Island, you can see that what look like very large rocks covering half the horizon. The elf explains that the rocks are all along the part of Desert Island that is directly above Island, making it hard to even get there. Normally, they use big machines to move the rocks and filter the sand, but the machines have broken down because Desert Island recently stopped receiving the parts they need to fix the machines. It's funny. It's funny that this is like all of a chain of things that are failing. It's like Desert Island needs some, like, stopped receiving some parts, and Island stopped receiving some sand, and the first one, which was I don't know, snow or something, Island stopped receiving water. So it's a fun it's a fun story in this way. You have already assumed it'd be your job to figure out why the parts stopped when she asks if you can help. You agree automatically. So yeah, I'm starting to suspect that we are actually like machines, whose purpose is to serve the elves. Like, we are always helping them, like unconditionally. And yeah, it's nice. I wonder if we will receive some hints of us being machines or what the hell we are in this story. Because the journey will take a few days, she offers to teach you the game of camel cards. Camel cards is a sort of similar to poker, except it's designed to be easier to play while riding a camel. So it's interesting that the link for poker goes to lists of poker hands, not to just poker. So I basically don't know how to play poker. I think I know what the hands are, like at least what is a full house, and well, some of these. I mean, yeah, five of a kind. I didn't know this. If you have the Joker, okay. I actually don't know. I have played poker just a few times in my life, so don't know much about it. I hope that we don't need that much poker knowledge for this puzzle. System restart required. Okay, don't bother me with this. This is a notification that I haven't seen before. In camel cards, you get a list of hands, and your goal is to order them based on the strength of each hand. A hand consists of 5 cards labeled one of A, K, Q, J, T, then 9 to 2. So I guess Ace, King, Queen, Joker, or how is it called? Jack of all trades, something like that. T, I don't know, tens. The relative strength of each card follows this order, where A is the highest and 2 is the lowest. Okay. Each hand is exactly one type. From strongest to weakest, they are 5 of a kind, where all 5 cards are the same label. Okay. 4 of a kind, where 4 cards. Okay, yeah. Full house, yeah, 3 and 2. 3 of a kind, yeah. 2 pair, sure, so here there are 2 twos and 2 threes. 1 pair, sure. And high card, where all cards labels are distinct. Sure. Hands are primarily ordered based on type. For example, every full house is stronger than any 3 of a kind. Okay. That makes sense. I think that's the same in poker, right? If 2 hands have the same type, the second ordinary rule takes effect. Start by comparing the first card in each hand. If these cards are different, the hand with the strongest first card is considered stronger. If the first card in each hand has the same label, however, then move on to considering the second card in each hand. If they differ, then the hand with the highest second card wins. Otherwise, yeah, continue with a third card in each hand, and then fourth, and then fifth. So these and these are both 4 of a kind hands, but 3-3-3-3-3-2 is stronger because its first card is stronger. Okay, so this is different than poker, if I remember correctly, because the order of cards in your hand doesn't affect its value, but in this game it does. So 3 is stronger than 2, even though like the 4 of a kind hand here is of aces, so that's interesting. Similarly, 7-7-8-8-8 and 7-7-7-8-8 are both a full house, but the first one is stronger because its third card is stronger, and both hands have the same first and second card. Okay, it doesn't specify what happens if the hands are like exactly the same, but I guess that won't happen. To play camel cards, you're given a list of hands and their corresponding bid, your puzzle input. For example, this thing. So, okay, the hand and how much you are bidding. This example shows 5 hands, each hand followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank, where the weakest hand gets rank 1. Were we told what a rank is? Oh no, so this part explains what a rank is. Okay, so when you sort the hands, that's the rank basically. The weakest gets rank 1, the strongest rank 2, and so on up to the strongest hand. Because there are 5 hands in this example, the strongest hand will have rank 5 and its bid will be multiplied by 5. So the first step is to put hands in order of strength. So, okay, I guess this thing sorted will be this. This is the only one pair and other hands are all stronger, so this gets rank 1. Then these and these are both 2 pairs, sure. Their first card both have the same label, but the second card of KK is stronger, K versus T. So this gets rank 2 and this one gets rank 3. Okay. Now you can determine the total winnings of this set of hands by adding up the result of multiplying each hand's bid with its rank. So the total winnings in this example are this. Find the rank of every hand in your set. What are the total winnings? Okay. And our input is just the list as expected, a list of cards, but it's a pretty long list, so I guess the total number will be kind of high. All right, I think this sounds like not such a complicated puzzle, or at least the part 1, but it will require some interesting modeling, I think. Let's open the code editor. So this was, I think I should just copy the template as usual. This will be day, how much? 7 camel cards. And let's also copy the inputs. Should I automate this process? Maybe, but eh. The real input, whoops, is this. Then our sample input is this thing. And then what we are expected for the sample is this. Okay, let's close everything else. And I copied instead of doing Control-B to close the sidebar. Increase the font size. All right, so where should we start? I think I'm gonna, well, I'm definitely going to model the card or the sort of hand type. And what I want to do is have like a list of hands and be able to ask each hand, like, what's your strength? Oh no, not what's your strength, but to be able to compare to hands. That's what we want. Implement ordering between hands and then just sort this thing by comparing each hand and then compute the thing that we want. Like, which is to multiply the rank by their bid, and that should be it. So let's first, as usual, parse the input. What are we going to do? Like, have the hands and bids, I guess. Yeah, I think let's just say let hands be input lines. We're gonna map each line to parse. I mean, if we're gonna have a hand type. My cat is on my lap turning around. Hey, say hi. Okay, what are we going to do? Okay, mapping to each line. We're actually not parsing just the hand. We're going to parse the hand and the bid. So let's say parse hand, well, line, parse hand and bid for this line, and then try collect. Okay, and this thing generates. This will be AOC result of what? Of a hand and our bit. Let's use 64 numbers. 64-bit number, sorry, and this would be a line. Okay, let's just call this thing parse line, you know? No need for such a verbose name. Okay, so what is a hand? What is a hand, indeed? I guess we could make the hands, well, I can make it a struct, I guess. Hand we have cards, which will be just an array of 5 cards. And what are the cards? I think I could use just a char, yes. I could also model like card type, but meh, let's just use 5 chars. And so when parsing a line, let's do what? Well, we're going to split the line into a hand and a bit. And this is just line split by, split once by a space, I guess. All of these have one space, right? Yeah. And add a return. Then now this is an option, so we are going to say okay, or invalid input, whatever. And then we're going to return I'm wondering if I should validate that the numbers on the hands are or the symbols on each hand are valid. I mean, that's not as strictly necessary, I guess, but on the other hand, like, I'm probably going to need some sort of like static array of the valid labels to know that, like, their strength. So, you know, it should be simple to validate this. And I'm now remembering the phrase or the motto of, like, parse, don't validate. So I should be parsing here instead of validating things, and that would mean, because like a single char can be any Unicode character, and that's not really what we should be allowing here. So if we would be like actually parsing and having here actually a card or a label, card label, whatever type we had, and this would be a proper enum with all the, I don't know, for 13 or whatever values that this has, we will have no option of here actually parsing this thing correctly and then not worry about having invalid hands. Whereas if we validate this thing, you know, you then have to worry about, like, what happens if things are invalid. But for this problem, I guess I'm going to just assume things are valid and have sane fallbacks. If we have an invalid input, it's like, well, it's unspecified, but at least try not to crash. Anyway, let's not think about the ordering of strength of labels or anything like that yet. So what we want is, well, what are we going to return? Here we're going to return hand chars, and can I just say into or try into, I guess, and then here similarly for the vid, I'm going to parse this thing, and if anything happens, just fail. That is, oh, this should be an okay thing with all of this. This try into now is failing because sure. So let's extract this and call this thing hands. And can I say to, I guess I could collect this thing into a vector of characters, and then you don't like trying to, why? Sorry. Oh no, not into. Yeah, this is we define it as struct. I was thinking about converting this into a five element array, but I guess we can do that if we say, okay, these are the cards, and then here we return a hand with just let's make everything very explicit. Let hand be a hand with the cards, and here I guess I need to convert a vector into an array, and I think this is fallible, so let's say try into, and does this work? Try into, why wouldn't this work? Sorry, I'm not understanding something here. Can't we let's be very explicit again, because I'm not understanding this the problem here. If we have cards being this, why don't you like this? Do I need to dereference this? Not really, but or take. I think. Do you want me to take a slice and then convert the slice? Yeah, ugly. Okay. Is this okay to you? Yes. All right, then. Can I inline you, please? Okay. And then maybe inline this thing. Yeah, that's not nice. Okay, with all of that being done, now this try collect doesn't like what we are doing, and why not? From an iterator, I guess I need to specify what we are collecting into. Yes, okay, finally. Yes, you can do this. Can we maybe print the hands? See what we got. So, yes. Derive, debug. Yeah, cargo run. Yeah, this thing, but this would be day 7. Camel cards. Day 7 input. No, not with a real input. Let's go with a sample. Yeah, I guess this is fine. All right. I thought that the parsing would take less time, but we got it then. Now, we should then implement ordering for cards, I guess. How are we going to do this? We have the hands. Let this thing be mutable because we want to sort them. And let's see. Let's say hands sort by, and these. Now what I want is sort by key, I think. And here I want to have the hand and the bid, and I'm going to ignore the bid and just sort by hand. And this will probably complain because hands are not. Yeah, this is what I need to implement. Ord, can you? No, you cannot say this. So impl ord for hand. Is this what I want? Yes, implement this. What's your problem here? Can't compare hand with hand. Oh yeah, I never remember this. Can't we derive partial ord from and then implement ord? Or is it partial ord? This is something that I never remember. Maybe it is partial ord, the one that we need to implement, and then well, maybe this is not the method that we need. Partials compare, and can we then derive ord? This complains because equality. Okay, we can derive equality, I guess, and equality can compare hand with hand. Yeah, partial equality, and this kind of thing is a bit less intuitive to me than it should. Like, why am I implementing partial ord instead of ord? Like, I think I should be able to implement ord. Let's actually look that up. Rust implement custom ord. Is the size of this too small? I think it is. Oh, it requires, so ord requires equality and partial ord. Okay, so you can implement partial ord and then derive ord from that, I guess. I mean, I don't really understand why this is the case, but let's roll with this. I guess if we have, in our case, when two cards cannot be, like when two hands are the same, but I mean, that's not partial ordering. It's like we don't have a specific way to compare them in the description, but that's not really what's going on here. What's your problem here? Lifetime may not live long enough. Return this. Where's that? Okay, sort by. I mean, longer than what? Can you You probably cannot do that because it's not copyable, so let's implement these two things. And then what's your problem here? Non-canonical implementation. What's your non-canonical? What? Implemented here. You want a canonical implementation doing self-compare, blah blah blah. Sure, if you want that, then why don't you let me implement? Well, let's do what Clippy wants us to do. Canonical implementation of blah blah blah. Now ord. Derive XOR ord XOR partial ord. Beautiful. So wait. Yeah, let me visit this thing. Come on, because I want to understand like really what Rust and Clippy wants us to do here. Okay, what's this for? I think it wants us to yeah, okay, but we need a partial ordering, so let's actually implement ord, and have no idea. Well, I have some idea, but I find this a bit more cumbersome than it needs to. So implement this. Okay, we are returning this ordering thing. Let's actually import this to access it. Was that the sound of my cat? Oh, cute. Okay, finally, how do we implement this custom ordering? Well, I guess we are going to be comparing. We're going to be first comparing the type of the hand. So, say hands. Let's do a self type. We're gonna compare. I guess we cannot call it type because that's a keyword. Let's call it type underscore. We're gonna have one of those. Then we're gonna compare with the other. The other hand type underscore. And I think this compare functions haven't like and something, but okay, let's first implement this type. So we could model this as some kind of enum or whatever. I am tempted to not do that and just return a number here. But let's see something. If we, well, let's say now it returns a value. But if we had like an enum hand type, and I don't know, I don't remember this. Can an enum derive OR and partial OR? Yeah, all of this, and maybe even EQ. That's like, do you like that? If that's the case, then maybe I could implement it that way. But I mean, there are 5 kinds of yeah, 5 types, or 1, 2, 3, 4, 5, 6, 7. No, sorry. So there are a few types of hands, but we are not going to be using that information for anything else than just like comparing them. So let's not fall into this. Although, I mean, it is nice to name these things, man. I always having trouble with this. So 5 of a kind, 4 of a kind. Let's bite the bullet and say 5 of a kind, then 4 of a kind, then it follows full house, then 3 of a kind, then 2 pair, 1 pair, high card. So 2 pair, 1 pair, and high card. Beautiful. And I guess this will be the lowest number. I think we want them the other way around, probably. But okay, let's compare these things by type. This is hand type, okay? And we are gonna do, well, we need to implement the logic of how the type for hand gets computed. So how are we going to do this? Basically, we need to what are the references? Yeah, we can group by their symbols, I guess. And like it depends on basically on how many pairs of symbols or types of symbols we have. So we could count the characters or the cards. Say self cards. Can we count or group? Or if we iterate, can we count? Count. What does count return? This comes from iter tools. Converts the item into a hash map which contains each item that appears in the iterator and the number of times it appears. I think this is what we want. Yeah, I think so. So let's assign this. Let's say let counts be this, and counts is a type of hash map. We can say probably, can we into iter this? And counts then is a, yeah, from card to usize. So now, what do we want to say? Well, if the counts length is 5, that means that all of the characters are the same, then we're gonna return hand type 5 of a kind. Then otherwise, what are we going to be asking? Basically, we don't care about, this is also interesting, like counts, we don't care about the key of these things, so basically we need the values here. What does into values does? Consuming iterator is all the values iterator. Yes, I think this is what we want, or something like this, but let's have the, because values is an iterator, right? Let's just collect this. Collect into a vector of usize. Don't like this because collect. Yeah, I want into values then. Sure. I don't need to say this. And now oh, I was asking if the length was 5, but I think I want to say if this. And actually, if we have the counts, this is interesting. If we have the counts, we could sort the counts, sort these things, and then say, hey, match the counts. And if it is 5, then we're going to return hand type 5 of a kind. If it is 1 and 4, this is hand type 4 of a kind. Then comes what? Full house. So this would be, if they are sorted, is 2 and 3. So this is hand type full house. What else could we have? We can have 3 of a kind, which would be 1, 1, and 3, right? Hand type 3 of a kind. Then 2 pair would be 1, 2, and 2. Type 2 pair. And what else do we have? 1 pair, which would be just different things, and a 2. Hand type, sorry, this is 1 pair. Then if we have just 5 ones, sorry, 1, 2, 3, 4, 5, this would be hand type high card, and anything else should be unreachable. Like we've made a bug if this is the case, I think. Can the compiler actually verify this? Probably not, right? There are some other thing you cannot compare. We want this. Okay, yeah. Yeah, I think it is complaining about a non-exhaustive thing, so yeah, it doesn't. No, right? Yeah, not everything is covered, so let's just say this is unreachable. Okay, so I think we have implemented comparing by hand type. Can we print than our hands. Let's println. Let's do simply for hands and bit in hands do println. Just print the hand cards. Okay, and we run this and we got something. First of all, is this in the same order? Sorry, is this in the same order as we had it? No, it's not. So it did sort something. Is this in the correct order? So we have a 3 of a kind at the top. In the bottom we have this is a high card. Then okay, maybe we are ordering the other way around, but this thing, yeah, is the only one pair. So it's a one pair. Yes, it's a one pair. So it's okay. Then these two. So yes, right, we have KK above 2 pairs. Yes, this is a 2 pair. This is the other 2 pair, but we are not sorting, like differentiated between these two. And then we have the other one. So I think we have to order by reverse. So the strength of a card, I guess, this is maybe a bit tricky. So we want to say that 5 of a kind is higher than 4 of a kind, for example. So I think that this is not sorting things the other way around. So let's, well, invert this thing. 2 pair, 3 of a kind, full house. Okay, so now it should be sorted. Yeah, correctly by type. But then we want to sort by the label of the labels of our cards. If this is like, if this is not, if the types are equal. So I think this thing has a then, yes. Then with, change the ordering with a given function. Yes, I think not sure if this is what I want. Returns self when it's not equals, otherwise calls f and returns the result. And f, yeah, f should return an ordering too. Okay, so we're going to compare by types and then with something else. And here we want to compare the cards, basically. But I want to convert the cards to their values, basically. So let's say self cards, and this is an array, so we can map to using a card value, let's say, a function, and then we're going to compare this, because arrays I think can be compared with the other cards map card value. Okay, I think this makes sense. And we want to have yeah, a card value function. So where do I put this? Let's put this after this impulse. Fn card value, this will take a card which is a label, let's say, which is simply a character, and it will return a usize, I think, because what I want to do is have an array with all of the values of cards, and let's say these are these things basically, and they are like the highest is A's, so we actually want the other way around, right? Yeah, probably. So let's say we're gonna have 2, 3, 4, 5, 6, 7, 8, 9. Then we're gonna have T, which I don't remember what it stands for. J, just J. Queen, King, Ace, if I'm not mistaken. Then let's have all of these be characters, and this is it. And this we are going to iterate or into iterate and find the, no. Can I ask for the position of something? No, I think I need to ask, okay, the position of predicates. Can't I ask for, can I ask like this? Card label. Position of. I thought. I thought that there was a, well, let's say label, so label equals card label. Okay, we have the position of this. This is already HR. So we're gonna have this and say unwrap or. So if we don't know about the card value, we're gonna say that the value is 0, like it's non-specified. And let's just return this thing. What's your problem with this? You want a reference, right? So borrow this thing. Okay, does this work? Now it's sorting like this, and KT something gets rank 2, and then KK, okay. Before we used to have KK and KT, so this is nice. And then this has a stronger first card, so it ranks 5, and this gets rank 4. Yeah, sure. Okay. I think we have successfully implemented ordering, although I was a bit sloppy on everything, so maybe I made some stupid mistakes. But I think that this makes sense. Sure, and then what's the last thing that we need to do? We need to multiply the bit with the rank, and that's it, and add all of those things, right? Yeah, okay, so let's answer 1, B. We are probably going to have to specify this type. So something like this. It's gonna be hands we're going to map, well, we're going to iterate them and map at the hand and the bid. And we're going to do hand. Oh no, we need to enumerate them. Enumerate and have the index, and then we're gonna have the hand, which we now don't care about, and the bid. It's called a hand, and we're gonna do bid times the rank, which will be I plus 1, and all of that we are going to sum. And you don't like this because there's some missing parentheses here, and this is probably wrong types of many things. If we do this, it's okay, but this is mismatched type, so we'll have this thing as U64 and be happy. Okay, is this println? Do we have the correct answer for part 1? (6440), yes it is. Okay, so if we run the input, we get this number. Let's try it out. Yeah, cool. Okay, so it was a bit of a mess when I was implementing things, but I think I don't have much experience doing these rusty things of implementing custom sorting and things like that. But this was okay, I think. We can not have debug here. The amount of things that I am deriving is, I don't really like doing this kind of things, but it's fine. Why were we doing this though? Can't we get away with when we are sorting? Because this thing was complaining about like a lifetime thing, but I don't understand this. Let's check this. Return this value requires that this must live. Okay. So what is it that you cannot verify here? It's weird, like sort by key. A reference to the hand, but I mean the reference to the hand should be bound to, should have the same lifetime as these hands. Oh no, although it does make sense. I think this actually kind of makes sense now that I think about it. Not entirely sure, because in order to sort by something by keys, it has to store the keys somewhere, and so it will need to copy these hands in order to do so. So I think this sort of makes sense. Yeah. Otherwise, we could probably do a sort by and have like a function that has a and b, and this a and b are going to be tuples, I think, yeah, and we can do a0 cnp compare with b0 and take a reference here, I think if we do that, we don't need to copy or clone things. And yeah, does this still work for the sample? Yeah, and for the real input is this number, which I don't know. Yeah, it seems to be my number. So yeah, this works too. And I think I prefer this to no, actually I prefer the previous one, was more readable what we are doing here. Okay, so I think that is it for part 1. Let's commit these changes actually. I probably want to have, so the check all, sorry, dot check samples, that's what I wanted to do, should work, but check all will not work because I need to save the answers. So now we should have an answers file with this answer that we expect. And if we do a check all now, it does the thing. So now we can commit everything and say add day 7 part 1 solution. Okay, let's take a look at part 2. It's a bit late, maybe I should get going, but let's at least read what part 2 is about. Part 2. To make things a little more interesting, the elf introduces an additional rule. Now J cards are jokers. Okay, I think I confused when I think the name of J's is like jacks on poker, but now they are jokers. Wild cards that can act like whatever card would make the hand the strongest type possible. The strongest type possible. To balance this, J cards are now the weakest individual cards, weaker even than 2. Okay, the other cards stay in the same order. So we have all of these, but now J changes order. J cards can pretend to be whatever card is best for the purpose of determining hand type. For example, this is now considered a 4 of a kind. Yeah, because the 2 jokers would pretend to be Qs. However, for the purpose of breaking ties between 2 hands of the same type, J is always treated as J, not the cards it is pretending to be. Okay, when breaking ties, so this is weaker than this because J is weaker than Q. Okay, yeah, it makes sense. Now the above example goes very differently. So this is the above example. This is still the only one pair. It doesn't contain any jokers, so its strength doesn't increase. KK677 is now the only 2 pair, making it the second weakest. And now these and these and these are now all 4 of a kind. Interesting. Very interesting. With the new joker rule, the total winning in this example is this. Let's actually copy this to our sample out that we want. Okay, using the new joker rule, find the rank of every hand in your set. What are the new total winnings? Interesting. Very, very interesting. So now we have jokers, and a lot of the assumptions that we had before are not valid anymore. So I wonder, did all of the things that we did stop making sense? Well, we could have another struct called like part2 hand and implement a custom ordering for that. Let's sketch something out real quick here. Let's say, okay, we have our answer 1. Okay, let's now do hands and sorts by, but we are now going to sort by something else. We are going to have A and B and do A0. Instead of compare, let's say compare part2. Yeah, part2 or part2 compare. And let's compare this thing with the hand in B operand. And after that, we are going to do the same calculation, but with a new order. So this is answer 2. Everything else stays the same, and answer 2. Let's generate this compare method. Let's move these actual compares, which is like the part1 compare, here. Maybe I would like to have some symmetry and instead of this thing being sortable, like have a part2 compare and do the same thing here. Well, but let's leave that for later. Let's now implement like part2 compare the same way, like this. And does this work? Consider removing the borrow because what? Part2 compare. Well, it's taking a hand. Let's take a reference like compare does, right? Because compare takes references to both. And this is going to be called other. And this should all combine it, I think. And if we run this with, well, let's run it with the input, we get 2 same answers. And if we run it with, let's do it with a sample, because we are going to want to have this number now. I want to check that. So, okay, what changes now? The type definitely changes. We now have to like consider what would be the type of the hand with this joker rule. And then we are going to compare the card values, but also the card values also change on part 2. Okay. No, this is not what I want to change. This is the thing that I want to change. And actually, you know, the part 2 is basically the same as part 1, but with jokers. So let's call it this thing compare with jokers instead of like part 2. And this is type with, no, I don't want to rename. I want to say this type with jokers. Yeah, and then card value again with jokers. Okay, so card value with jokers should be pretty easy to implement. I think it's the same as card value. but the j is the lowest. Okay. Everything else stays the same. Probably can avoid some of the repetition, but whatever. And type with chokers is gonna be, I think, quite a bit more difficult. So what are we going to do here for type with jokers? So what I'm thinking is I would probably want to replace the jokers in our cards to take the value that would make the hand the highest type possible. So how would that be? Let's see some of the examples here. So this, for example, would be a 4 of a kind, because the jokers will take the value of Q. So, it's not just the jokers taking the value of the highest value card that you have, because if, well, this is a 2 here, but imagine that this 2 was an ace, and the ace would be the highest value, but if the jokers would take values of ace, this would be a full house instead of a 4 of a kind. So we want the jokers, I think, to take the value of the card that appears the most times, I think, with the highest count. Is that what we want? Maybe. Would that work for every kind? So imagine if we had like a high card situation with a joker, then changing the joker to, well, whatever, or all the jokers there to whatever. Imagine if we have like one joker, then we change it to any of the other cards, then it would be a 1 pair, and that's the highest that we can get. If we have 2 jokers, then changing it to 3 of a kind is better than changing it to two pairs, so that still makes sense. And if we had 3 jokers, making them all be 4 of a kind is better than a full house. So that also makes sense. If we have a single pair and we have 1 joker, then making that joker be a 2 pair is worse than being a 3 of a kind. So in that case also works. And if we have 2 jokers, making it go into 4 of a kind would be better than going full house for the 1 pair case. So yeah, it seems like converting all the jokers to the card that has the highest count would be, I think, is the strategy to go. So types with jokers. How are we going to do this? We can, let me think. I want to see like the card that has the highest counts, and it's not a joker, and then convert all of the jokers to that. That's what we want. So how do we do that? Self cards. I guess we can filter the things that are not jokers and get the counts and get the highest count, something like that. Do we have? Let's look in the sample. We have two jokers. Let's actually check the input for day 7. So there's a lot of jokers around. Sure. Do we have like 4 jokers? Oh, look at that. We have 5 jokers. Oh, this is an this is an interesting edge case that I wasn't thinking about. This should be considered like 5 of a kind, but we don't have another card to convert the jokers into. So interesting case. Okay, so how do we do this? I guess we can start taking the counts. Cards eater. Yeah, and counts maybe. If we say remove if we remove the choker, or yeah, let's just remove the chokers, or just filter the ones that are not. So see that that are different to jokers, and that's it. And C is car reference. Sure. Now this could be empty, the counts, because we know that there is at least one example in the inputs that has all the jokers, which is a really nice card to have. So what we want to have, like the card with the highest count. So let's say counts yeah, something like eater, and get the max by key, card and count. This, and of course it might be empty. Oh, we want to have the max by key, but then we want to have the card out of that too, right? So okay, man, it's complicated, this thing. There's so many double references. Sure. Is this a very stupid way of doing this thing? I think it might be, but let's see, we want the card with the highest count that is not a joker. Okay, max by blah blah blah. Then we are going to map this thing to the card itself. Okay, and we want to have this and wrap or, and so if we don't have any card besides the jokers, then I'm going to put a fallback and just make it an ace, because why not? And let's say let's card with or highest count card be this thing, and all of these highest count card is of type we can dereference this, we can, what's your problem here, lifetime blah 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 blah, let's like dereference this thing. Okay, let's make this thing actually card count like symmetrical to this. We are going to map to card is here a char, so maybe if we do this and this and this, still compiles, yes. So we have the highest count card now, great. So I think that we can do replace the in our cards the highest count card with, sorry, all the jokers. We are going to replace all the jokers with these. So how are we going to do that? If we say, for example, let's mute new cards is self cards. Can we copy this? New cards is, yeah, the correct thing. And we can say new cards, can we replace the font size of this is so small, I don't know if I changed something on my system. So Rust replace all in vec. This is not what I want. I mean, let's do it the simple way, I guess. We can simply map here and say, okay, map the card. If the card is a joker, then we replace it with the highest count card. Else, just use the card. Okay, that's the new cards. And finally, I think that we can delegate this and say create a new hand with these cards. So cards is new cards, and ask for its type. So does this work for the sample? I don't know, is this the number that we are hoping for? Yes, it is. Okay. Does this work for the input. It didn't explode. It gave us a very similar number, but not quite the same. Is this correct? Yeah, it is. Okay. I'm surprised that this worked first time that we run. Because I don't really trust this logic that I did here, but apparently it is correct. So yeah, I'm pretty happy to have gotten this on the first try, actually. Awesome. So yeah, let's maybe review the code and call this thing done. Let's add this actually to the changes and also update the answers. And let's check all. Yeah, everything runs correctly. So we can probably extract this thing into a function and not repeat it, but not really important, I think. Here we are comparing with things with the jokers, and that's also cool, I guess. But I mean, it's not like these hands have a natural way of being compared, because we are like it's two different comparisons. Types with jokers compare with jokers, yes. So I think that hand type, blah, blah. I was thinking about maybe naming some of these things differently. So yeah, this is fine, I guess. Yeah, let's see what happens if we actually move this compare function into here, types with jokers. So just call it compare no jokers. And don't do anything of this order and compare and blah blah blah, and maybe we won't even need to derive anything here, and instead just do a sort by and call this thing explicitly compare and no jokers. And I think that this still compiles, and if we check all now, yeah, things still pass. So I think that is simpler than having a natural ordering for the hands, right? Yeah, I think so. Because the custom compare for part 2, when you compare things with jokers, is like you still have to although it is kind of a natural way of comparing, like we can also say like the natural game is without jokers. Yeah, kind of. I am actually regretting that. Let's leave the custom ord. Also to like have a reason to remember how to implement custom ordering. I think that is fine. Maybe let's extract this into a little function and call it whatever we were calling this on the example. Oh, look at this. We are now on the floating island, the desert island. So how do we call this thing? What are the new total winnings? That is what we are computing. So let's call this thing, oh, where is my function? Here. Total winnings. Total winnings for our hands and bids. So sure, we don't need to now declare this, and we can now do the same for answer 2. Oh, okay. Okay, cool. Total winnings, this is fine how we are calculating this. We can maybe, I don't like mixing this dereferencing thing here because it gets confused with the multiplication. So maybe the reference, or yeah, let's take a borrow here. This is fine, or maybe even only for the bid. Are you happy with this? No? Why not? What's your problem? Like it likes one but not the other? Yeah, sure, do that. No worries. So the main code now is pretty good, I think. Yeah, total winnings is fine. Then we have the hand definition and hand type, sure. The comparison code, this partial order is like, I don't like this, but whatever. It's the canonical way. This type underscore, maybe we can rename this to be like simply hand type. Yeah, why not? And for consistency, let's call it hand type with chokers. So here we are comparing the hand types with chokers of these two, and then we are comparing their car values with jokers, which is fine. Yeah, it's the position. Sure. There's some repetition between these two, but what changes is this this array of values. But maybe I would like to have them side by side to know what changes between them. So maybe can I put this into, well, we can put it into a variable and then promote to a constant. And if we put this outside, card values, or it's another card values. This is the card sorted cards, I guess. But this is not better than what we have right now. So let's leave this as this. What changes here is that when you have jokers, jokers are the least valuable card, and that's fine. And then the parsing, which is okay, I think. We get the cards by getting the characters here, and then yeah, converting those characters into a static array. This is fine, sure. So the only well, and this code actually for the hand type is actually, I think, pretty good. I think it's pretty clever to like sort the counts, and then we have all the possible hand types here. So I'm pretty I'm pretty okay with this. And then this is maybe not so okay. Hand type with joker. So highest count card. Max 5 key. Okay. Yeah, but it's not so bad, I think. This may warrant a comment, I think. If there are no cards besides, if hand only has jokers, of just jokers, replace them with a valid label. Then with a valid label, yeah, like aces. Sure. And new cards, this instead I would call this well, new cards is fine, right? Or like these are the cards that will make the hand the highest possible type, but yeah, let's call it like cards with like super explicit with jokers replaced. Okay. Oof, what happened there? Okay, what happened here is that, man, this is very ugly formatting. Let's actually call maybe these hand with jokers replaced. Okay, and this is just a hand. And maybe inline this thing. Yeah, sure. Yeah, it's not that bad. If the card is a joker, you replace it with highest count card. Yeah, I mean, I'm not very happy with the formatting here, but at least the naming and stuff makes the code be, I guess, pretty understandable on what it's doing. So, okay, I think that's enough of a review. Let's add these changes and commit this. So add day 5, no, day, what is it, 7, part 2 solution. And that's it, I think. Okay, so today's puzzle was, I think, pretty, I don't know how to call it, like interesting in modeling, I guess, problem. It was not difficult to reason about, or maybe not part 1. Like part 1 was everything modeling the hands, modeling the ordering and that sort of thing, which I think sometimes it's nice to do. And in part 2 we had to think a little bit about how to replace the jokers with the correct card to make it the type of the hand the highest possible. But it was pretty fun and not so complicated, as you can see, like with the amount of code that it needed. So I think that is it for today. Oh, before I forgot, I should, as usual, do a thumbnail, I think. So let's show the shape of the code here. Look at this beauty. Let's show the hand with yeah, I think this is the prettiest code in here. Here we can say toilet something. So this is EOC day 5. Camel carts, maybe. Let's look at. Oh no, what's going on? Oh, I'm missing something. Yeah, the extra thing here. So let's actually clear the screen and do this. Sorry. Yeah, that is a nice color, although it's not very desertic, but I think that's going to work. And this code is nice. So that's it for today. This is a fine thumbnail, and see you later, I guess. Goodbye.